Okay, here we go. 4.3 ionic compounds and 4.4 naming binary ionic compounds. I'm going to approach this part a little bit different than what's in your book, just because I found that students get it a little bit better if I explain it naming compounds in 4 different ways. So a quick review. If we take an element, say arsenic, we would want to be able to write the noble gas configuration for it, for arsenic, and we would want to be able to do the Lewis dot. So let's do the noble gas configuration for arsenic. Arsenic is number 33, and so we would take the noble gas that's closest to without going over, which would be argon, in brackets, and start from there. From argon we would go 4s2, 3d10, and 4p3. Remember that we need to rearrange that, and it becomes argon, 3d10, 4s2, and 4p3. Now to do the noble gas configuration, or sorry, not noble gas, but to do the Lewis dot for argon, or for arsenic, we would want to draw arsenic symbol, AS, and since we have 2 in the S and 3 in the P, we'd go 2 in the S, 1, 2, 3 in the P. Now looking at arsenic here, remember we talked about it wanting to, all elements want to be like a noble gas. In other words, they want to have 8 in their outer shell, and they can do it one of 2 ways. They can get rid of the electrons they have and be like the noble gas below them, or they can gain electrons and be like the noble gas above them. But they need 8 in their outer shell. Well, this one only needs 3 more to be like a noble gas. So remember we talked about that would be a -3 charge. We can write it a couple different ways. So it would gain 3 electrons. So we could write arsenic will gain or add 3 electrons and become As -3. Now we could also do that with any other element. Say that we wanted to do calcium. Calcium has 2 in its outer shell, so we've done it like this. And remember, calcium is actually going to lose those electrons to become like the noble gas below it, which is also argon. And so when I write the equation for that, I would say calcium would lose 2 electrons and become calcium plus 2. Now, we can take and we can try and put these 2 together, calcium and arsenic, into a compound. And to do that, what we want to do is consider it like this. We want to be able to add these 2 charges together and get a 0 overall charge. We can take and times each of these by a number. Well, if I look at that, 2 and 3 has a common factor of 6. So to get 2 to 6, I'm going to have to times it by 3. And to get a -3 to a -6, I'm going to need to times it by 2. Now that will tell me how many calciums and how many arsenics I need. And so when I write the formula for calcium arsenide, I would write Ca3As2. And that's what I would write. Now to name it, since calcium is in the first 2 columns, we would say calcium. We'd name the first and name the second, changing the ending to IDE because it's just an element. Ars, forgot the A. Try that again. Arsenide. Okay, probably put an E in there. And we've got the thing. So now let's go forward here. We're going to go into what I call type 1 naming. Okay, type 1 naming has to do with anything that starts in the first 2 columns, not including hydrogen or helium. So what we would call the S block. So if anything starts in the S block, not hydrogen or helium, so we're not going to count those, okay? So those are not going to be part of this. We'll talk about hydrogen later, and helium's a noble gas and it doesn't like to make compounds. So if we start with any of those, for instance, say I have MgCl2 and I want to name it. So what I do is I name the first, which is magnesium. Then I name the second, which is chlorine here. But since chlorine is the negative part of that, I say chloride. Anytime it's just an element, we're going to change the ending of the negative element to IDE, ide. Okay? If I have something, say for instance, strontium, with a polyatomic or a group of elements that has a specific charge, like those on the back of your periodic table, say, let's put it with phosphate. So I'll have to write like this, because strontium is a +2 charge and phosphorus is a -3 charge. So in order for that to equal 0, I need 3 strontiums to go with 2 phosphates. And whenever I need more than one of a group, I put it in parentheses. So to name this one, I would just name the first strontium. Name the second, which is a PO4, and that is phosphate. And I'm done. I don't change the ending of a group that already has a name. Okay, let's take one all the way where we have the compounds and then make the formula and then give the name. So let's take, excuse me, Ba, which has a +2 charge. From your periodic table, it's the second column over, and so it's going to have a +2. Everything in the first column has a +1, everything in the second +2. So barium has a +2, and let's put it with chlorate, and this is a polyatomic that is on your chart, and it has a -1 charge. So these two have to add to equal 0. In order to make this happen, I need 2 of the chlorates to make that mathematical equation work. So what I have to do is put around the chlorate parentheses and put a 2. Now when I actually write that, I'm not going to leave the positive and negative up there. I'm just going to write Ba parentheses ClO3 parentheses 2, and that's what I would write down. I wouldn't write any of this. This would be gone. Now to name it, I just go ahead and name the first, which is barium, and name the polyatomic it's with. ClO3 is chlorate. And I'm done. So that's type 1 naming. You should be able to do that fairly easy. Okay, type 2 kind of naming is when you have something in the D area, the F area, or the lower P area. These are metals that have many charges. So we've got to remember they're metals and they have many charges. Now because they have many charges, we have to let people know what charge that we're using. So for what we do for that is use Roman numerals. So that you remember your Roman numerals, let me list those up here. Okay, so I've listed 1 through 10. Now you'll probably only use 1 through 7, but I wanted to make sure that you had all of the Roman numerals you might possibly need. So what happens is if you have something like this, if you were given vanadium like this, you have to sort of work backwards to find out what charge it has. So I know that oxygen has a -2 charge, and I have 5 of them. Plus, I also know that I have 2 vanadiums that I don't know the charge of. But I do know that this has to equal 0. So if I look at this and simplify a little bit, I find 2x minus 10 equals 0, 2x equals 10, x equals 5. So the charge on vanadium is a +5. So what I do to write the formula for this now is I would say vanadium, put the Roman numeral of the charge for vanadium, and then put oxide. So I've now used the Roman numeral 5 right here to tell the charge on vanadium. Let's do a couple others. Okay, so here's copper 2 phosphate. Remember the 2 tells me the charge on the one before it. The Roman numeral tells the charge on the one before. And it's always positive. So I have Cu and it has a +2 charge. Phosphate is one of our polyatomics. So we look on the back of our periodic table or on that bright pink sheet I gave you. And it's PO4 and it has a -3 charge. Now the easiest way to remember how to figure out how many of each is, say, okay, what's the common factor between 2 and 3? Well, it's 6. So what do I need to times 2 by to get to 6? 3. What do I need to times -3 by to get to -6? A 2. So that becomes our subscript. So Cu gets a 3 and PO4 gets a 2. But we got to remember, whenever we have polyatomics, we have to put it inside parentheses if we need more than one of them. If we don't need more, don't use parentheses. But I need 2, so I'm putting in parentheses and putting a 2 on the outside. Okay, let's do another one. Say that I had chromium. We'll go backwards again. Cr3 PO4, we'll use the PO4 again, 4. So now I want to go backwards. I know PO4 is a -3. I just figured that up above. And I timesed it by 4. That's going to add to 3 times some number to get to 0. Well, that means 3x minus 12 equals 0. That means 3x equals 12 and x equals 4. Okay, so that means chromium has a +4. So when I go to write the name, I write chromium, parenthesis, Roman numeral 4, close parenthesis, and PO4 was our phosphate. Okay, this is naming type 2. Fairly easy. Just remember that the Roman numeral tells the charge on the first one. Okay, so type 4 naming, and yes, I'm skipping over 3, we'll come to that at the very last. Type 4 is acids, and acids start with an H, and H has a +1 charge. So there's 2 types. I'm going to split it up. The first type, we'll call it type A, is binary. So if it's binary, that means it has hydrogen and one other thing. If it's binary, this is how you name it. You say hydro to represent the hydrogen. You say the base name of whatever it is, then you add ic and add acid. So if I have HCl, it would be hydro, chlor, ic, and then acid. If I have HI, which is supposedly the friendly, not friendly acid, it says hi, but it then eats you apart, I would write for the name hydro, iodic, acid. Okay, fairly simple. The second type has to do with hydrogen and a polyatomic. So it's called an oxyacid. Okay, an oxyacid. So on the polyatomic, if the polyatomic, that's that group of elements that hangs together and has a charge, ends in 8, then it's going to change the ending to ic and add acid. Now the way I remember this is I love Thanksgiving dinner, but I always eat too much and I'm always sick after. So 8 goes to ic. If the ending is ite, if it ends in an ite, then it's going to go to us. And this is how I remember. And then acid. This is how I remember this one. If it ends in ite, I want to fight, and it takes 2 of us to fight. So silly ways to remember, but if it helps you, great. So for instance, if I have the acid H2SO4, the H just tells me it's an acid, so I write acid. Then I ignore it. Then I worry about this, SO4. SO4 is a sulfate. Sulfate goes to ic, so I get sulfuric acid. And I do end up putting back the UR or the OR for phosphor, just because it's better, it sounds better than sulfic or phosphic. That's, I don't know why they do it, but they just do. Okay, so let's look at another one. Let's take H2SO3. SO3 is sulfite, so it's one less oxygen, so it's going to fight, and it's going to take two of us to fight, so it becomes sulfurous acid. Same thing's going to happen with any polyatomic. If it ends in ate, it goes to ic and acid. If it ends in ite, it goes to us and acid. Okay, pretty easy for type 4. Okay, for type 3, binary covalent bonding, both things have to be in the upper P. That's this part that I shaded in red. They both have to be in here, the one that starts it and the one that ends it. And binary compounds are just that, binary meaning 2. You already know how to name this. You've already been exposed to this. You know what CO2 is. What is it? It's carbon dioxide. What are you doing? Well, you're telling me how many of each you have. If it's just one on the first, we don't worry about mon. Now, CO is carbon monoxide. So look how I'm just telling how much of each thing I have. So let's talk about the prefixes really quickly. So 1 is mono, 2 is di, 3 is tri, 4 is tetra, 5 is penta, 6 is hexa, 7 is hepta, 8 is octa, 9 is nona, and 10 is deca. Now you're probably not going to get up past that in what we're doing. So let's look at a couple and see if we can name them. So let's take N2O5. So we're going to name each part of it. I have 2 nitrogens, so it's going to be dinitrogen. How many oxygens do I have? 5. So I look at penta and say pentaoxide. Okay, what about CCl4? Well, carbon, there's just one. I don't have to put mono on the first one. In fact, they don't want you to. And then I have tetrachloride. Let's do one more. Say that I had OF. That would be oxygen monofluoride. Okay, so pretty easy, type 3. Okay, so you need to be able to name each type 1, 2, 3, and 4, write the formulas, and be able to tell me what's happening. Is it gaining or losing electrons? Now, there's a little quick trick, and we'll learn more about it later, but it's Leo and Ger. Leo is loss of electrons is oxidation. So if I have something that's losing electrons, say aluminum is losing 3 electrons to become Al plus 3. It's becoming positive. I like to look at this. Hey, I lost weight and I'm becoming positive. Yippee! Now Ger, on the other hand, growly, I'm starting with, say, sulfur, and I'm going to gain 2 electrons, or gain weight, and therefore I'm going to become negative by 2. Overall, I'm negative. Negative is Ger. Gain of electrons is reduction. So I'm either reduced or I am oxidized. So those are some quick little things. We'll be using them later in the year. But you need to be able to identify which one is gaining and which one is losing electrons, and be able to write the formula, the reaction like this for them. Now if you were to put these two together, you remember, you're going to try and balance the charge, so you have Al plus 3 and S minus 2. They're going to add together to equal 0, so I'm going to need 2 of these to go with 3 of these. That means a 2 here and a 3 here. And to name it, I would just say aluminum. Now aluminum is one of those that are in our slide: boron, aluminum +3, zinc +2, silver +1. So because of that, you don't have to put the Roman numeral with it, but it's not wrong if you do. So if I did put a Roman numeral 3 here, I'd be okay, but you don't have to on that one. Okay, you don't have to, but you could. And then I just name the element it's with, which is sulfur, change the ending to IDE, so it would be sulfide. Okay, so aluminum sulfide, or aluminum 3 sulfide. All right, I will see you for the next set. See you in class.